Okay, we're going to look at moving on to systems of linear equations. And there's going to be several ways to solve. The first way is going to be by graphing. So this is not on Schoology. You already know where it is because you're watching it. So you want to take notes while you're watching this. First of all, you have to understand what a system means. We're going to say that a system is more than one equation. Okay? And one way to solve a system is to graph it and find the solution. So on this guy here, this is my system for number one. It's got two equations in it. And the solution will be anything that satisfies both equations. If you remember back to what we talked about to satisfy equation, this point satisfies neither equation because it's not on the line. So this green point doesn't satisfy the pink equation or the white equation. So the green is definitely not the green point's not a solution to the system because it doesn't satisfy either equation because it's not on the line. All these pink points, which are anywhere on this line, right? There's an infinite amount of them. They all satisfy one of these equations. That's this one. This line here is the pink equation. The white points, and I'll put in some other ones, but there's an infinite amount of points. They all satisfy the white equation because they're on the white line. There's only one point that satisfies both, i.e. that's on both lines. This point right here. This green point is on the pink line and it's on the white line. So therefore it's satisfying both equations, meaning if I plug it in, it makes them true. So how do we come up with that point? We graph both of these lines. So both of these lines are in slope-intercept form. So I graph the y-intercept and then I use the slope to find the second point. So we'll go over this in the next problem. Mr. Rosicki already did this one. Once I graph them, I find that point of intersection, which happens to be -3, and then down 1, 2, 3, 4, 5, 6, 7, -3, -7. So that's our solution. It's the point that is on both lines. Therefore, these three dots mean therefore, it satisfies both equations. Let's see what that means to satisfy an equation. If I take the point -3, 7, and I take the first equation, and I plug the -3 in for x, and the -7 in for y, I get this statement right here. If I simplify that statement on both sides, I get to a true statement in the end. That's what it means to satisfy an equation. Now, that point, I want to show that that point also satisfies the second equation. So I take this x and y point and I put it into the second equation here. I simplify down to this statement, which is also true. So therefore, that point also satisfied that equation. So the solution is correct because it satisfies both equations, or you could just say it's true. You got a true statement from both checks. All right, so let's try number 2 here. So this line, I got to graph it first. I know that its slope is 2/6, which I know reduces to 1/3. And the y-intercept is 0, -5. So again, I knew that because this is in slope-intercept form, y equals mx plus b. So first I graph the y-intercept at 0, -5. Then I use the slope to find the next point. So the slope was 1/3, so I go up 1 and right 3. Go up 1 and right 3. I just keep doing that to get all these points. I'm going to want all of them because I want to find the intersection. So that's the green line. Graph that in green. Now I'll do this other one in white. So the slope of this line is 1/3, and the y-intercept is 0, 6. 1, 2, 3, 4, 5, 6. So I'll graph that y-intercept first. Now I'll use the slope to get other points. So I go up 1 and right 3, up 1, right 3, up 1, right 3. Oh, I only went 2. Then I'll go the other way, down 1, left 3. It's the same slope, right? Down 1, left 3, down 1. Okay, so then we have this second line here. And this has no solutions. Write my answer purple. No, that's not pink. Why are there no solutions? Because these lines will never intersect, and solutions are anywhere where the two lines intersect, any point that's on both lines. So there is no point that I can plug in that would make both equations true, so I can't check it. How do I know that these lines will never intersect? I know that they're parallel and they'll never intersect because their slopes are the same. So if they never intersect, there's no solutions. So parallel lines have no solutions. Okay, let's take a look at the next one. I'll do the first one in green. So if I graph this line, my slope is -1/2. My y-intercept is 0, 2. So I'm going to start with graphing 0, 2. And then use my slope. Down 1, right 2. -1/2. So down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. I'll go up 1, left 2. It's the same slope in the other direction. So there's that line. Now let's do the second line. I'll do that one in white. The slope is -3. The y-intercept is 0, -3. So if I graph 0, -3, start there, and then use my slope. So slope of -3 means it's like -3/1 when I'm graphing. So I would go down 3 and right 1. I can go up 3 and left 1. That's the same slope. 1, 2, 3. 1, 2, 3. So if I draw the white line, I can see the lines do intersect. They intersect right here at that point. That point is, it's -2, 3. -2, 3 is the solution. I'll say because it is the point that lies on both lines. That's how we figure it out graphically. We can check by taking each equation, y equals -1/2 x plus 2 and y equals -3x minus 3. See if it satisfies each equation. So remember, this is my x and this is my y. So 3 goes in for y. -2 goes in for x. So 3 equals -1/2 times -2 equals 1. And then I got my 1 plus my 2. I get 3 equals 3. So check. It satisfies. The solution satisfies the first equation. Now let's check that second one. If I plug in my, y needs to be 3. So 3 for y and negative 2 for x. I get 3 equals, first I'll do this multiplication here. Negative 3 times negative 2, I get a 6, and then a 6 minus 3. So then I get 3 equals 3. It checks. So the solution satisfies the second equation. So therefore, it's a solution to the system. Remember, the system means both equations together at the same time. There's the solution to our system. It satisfies both equations. Let's take a second here and look at something that's not a solution. Like, let's say this point right here. That's 7, 0. The point 7, 0 is not a solution because it's on neither line. So it will make both of these false. Like if I take the point 7, 0 and I take this first equation and I put in the x and the y, put in 0 for y. Actually, I'm sorry. Let's do it for the second equation. We'll take this second equation. I plug in the 0 for y. I plug in the 7 for x. I get 0 equals, I'm going to multiply these first, so I get negative 21 minus 3. 0 equals negative 24. That is a false statement. So that means it did not satisfy. 7, 0 does not satisfy the equation. Seven zero does not satisfy the equation. That means it's not a solution to the system. It's not even a solution to that line. So I wanted to have you look at what happens when it's not a solution. You get a false statement right here, which means it does not satisfy the equation. This point did not satisfy that equation. That's what it means. That's how you check if it does. All right, so the solution to the system will satisfy both. All right, let's take a second and graph line number 4. Now, the first line of number 4, I'm going to do that one in green. Now, this one is in standard form. So to graph, we want to graph the x and y intercepts. That's the best way. So if I plug in 0 for x, I've got, I'll write it over on the side, y minus 3 times 0 equals 4. And I solve for y, I get y equals 4. So there's one point on my line, 0, 4. Now I'm going to plug in 0 for y. So I'll do that here and solve for x. So if I plug in 0 for y, I get 0 minus 3x equals 4. So I get negative 3x equals 4. So x equals negative 4/3. So I'm going to say that's about negative 1.3. All right, so now what happens here is we run into a problem where it's not easy to graph this, so it's going to be hard to find our point of intersection. So in this case, graphing the standard form this way doesn't work that great. For these solutions here, when we're trying to find points where they intersect, we're going to want stuff in slope-intercept form. So it's going to be better to just convert it by solving for y. So if I add 3x to both sides, I get y equals 3x plus 4. And now it's in slope-intercept form. So I have my slope is 3, and my y-intercept is 0, 4. So yeah, that's how we're going to do these for solving systems. We kind of want to always have them in slope-intercept form. That's going to help out in graphing to find the point of intersection. So let's graph this first point, this first line. I've got a y-intercept of 0, 4. And now I'm going to do a slope of 3, which means 3 over 1, right? So I go up 3 and right 1, up 3 and right 1, down 3 and left 1. So here's our first line. Now let's look at this other line. The slope for here is 3 and the y-intercept is 0, 4. So if I graph 0, 4, I'll do this one in pink, and I do my slope of 3. Oh wait, this ends up being the same line. It's just going to graph right on top of itself. So how many times do these intersect? When the two lines are exactly the same, they intersect an infinite amount of times. They intersect at all these points. There's infinitely many solutions. Another good reason to always change into slope-intercept form, because you can see right here they're exactly the same line. So that's infinitely many solutions we don't need to check. Every point's going to work that's on that line. All right, so let's look at number 5. Let's put those into slope-intercept form. So I want to solve for y. I'm going to add x to both sides here. So I get y equals, if I add x, it's going to be positive x minus 7. That one has a slope of 1 and a y-intercept of 0, negative 7. So I'm going to go graph that. 0, negative 7. And then I'm going to use the slope, which is 1. You could think of it as 1 over 1. So I go up 1, right 1, up 1, right 1, and it just keeps going like that. There's our first line. Now I'll do the second one in green. To put it in point slope form, we're going to subtract 7 off both sides. So I get y equals 5x minus 7. So my slope is 5, and we can think of it as 5 over 1 for graphing. And my y-intercept is 0, negative 7. So I graph 0, negative 7, and then I do my slope. Hey, I found the point of intersection right away. It's the y-intercept. Let's finish this line anyway. The slope was 5 over 1, so I go up 5 and right 1, up 5, right 1, and so on. And those two lines have a solution right there where they intersect. That point is 0, negative 7. So that is the solution. I want you to finish the check by plugging. You can write your original equations, y minus x equals negative 7, and y plus 7 equals 5x. You're going to check by plugging 0, negative 7 into both of these and see if you get true statements. Since it's a solution, both statements should be true, meaning the solution will satisfy both equations.